I have the good fortune of introducing to you today Dr. James Ferry, who is the co-director of the Ideal Center for Innovation at Lafayette College. He's a world researcher, a world traveler. He's been in places ranging from Beijing, China, to Florence, Italy, to Potsdam, Germany, and has completed over 40 technical research papers. We're looking forward to his presentation. Dr. it's all yours.
Thank you, and I'd also like to thank the organizers for inviting me to share some of the things that are happening at Lafayette College, particularly in this forum where there's a wide diversity of perspectives and approaches, and so I hope to be able to add to that array of expertise that you are becoming familiar with in the Eastern Pennsylvania. So. As was mentioned, I am currently working as a part of the Ideal Center for Innovation at Lafayette College, which is a combination of kind of innovation, design, entrepreneurship, and leadership, which is really quite an amalgamation of different things. So there is definitely a focus on entrepreneurship, but where we kind of diverge from a straightforward E-Center is that we have assets associated with design and particularly manufacturing that complement the ecosystem of entrepreneurship at Lafayette College and also in Eastern Pennsylvania. And so at Lafayette College, for those of you not familiar, it's a small liberal arts college that also is celebrating this year 150 years of engineering. And so that kind of unique combination in a liberal arts environment together with strong technical education creates very interesting opportunities. And so what the Ideal Center seeks to do is to serve as a platform, particularly for engaging external partnerships and facilitating experiential learning, so with kind of curricular and co-curricular opportunities, and really to help students to focus on projects which have durable impact beyond the classroom, i.e. when the semester finishes, it is the hope of the Ideal Center that projects would have a durability beyond the typical semester period or beyond the academic cycle. And you can find out more at ideal.lafayette.edu if you're interested in reviewing annual reports. So what I wanted to talk about today was to complement Dr. Vinci's presentation talking about opportunities for industry academy collaboration. And so someone explained to me very early in my career that the goal, or one of the primary objectives in presentation skills is to steal content from other people so that you don't have to spend lots of time preparing it. So the NSF nicely prepared a summary of one of the kind of fundamental problems of funding academic research with the intention of commercialization, and that is the so-called valley of death. And so the mission of the National Science Foundation is to promote basic research, but with the obvious intention that commercialization is a part of that horizon, right? And as we think about how we go across from the academic environment into kind of commercial applications, there's a valley, and that valley finds its place because typically of a lack of resources, and yet those enabling activities really feed commercialization. So as Rick mentioned earlier, there's a whole variety of different funding mechanisms, kind of ranging from the fundamental to the translational, all the way, as Rick mentioned, the IUCRC or the STTR, SBIR programs. You can find out about those either by looking at Rick's presentation to see where the web links are, or just going directly to NSF. Those are nicely hosted. But what I wanted to do is share a little bit about how the Ideal Center at Lafayette is working in these areas and how we've implemented, let's say, translational activities in co-curricular and curricular programming as well as sponsored research projects. And so a couple of key programs that we kind of made the centerpiece of 2015's activities were the Additive Manufacturing Institute, which is a new organization that we've started at Lafayette College focusing on metal 3D printing, but really as you understand, there's a whole ecosystem of 3D printing that if you start at metal, it's really a very big jump to kind of enter into 3D printing through metal media. But there's a few other things, obviously, that we focus on. All of them have a translational bent. And so I just wanted to quickly include a slide like this, which kind of shows really the potency of doing these kinds of STEM-type projects in a liberal arts environment. Right, and so this program focuses on cultural conservation and nanotechnology, and I like to use as kind of a tagline, no ifs, ands, or buts, nanotechnology can be used for cultural conservation. So the fresco that you're seeing up there is on the ceiling of that of the Florence Dome, and it was in such a state of disrepair and such an important part of cultural heritage that interventions by conservators were actually prohibited because it was so risky to undertake restoration. And one of the kind of the prime objectives of conservation activities is to restore the work of art with the original chemistry and original materials without manipulation of artistic intent, which really means the pigments have to stay where they are. And so what you're looking at just quickly there, going from the left to the right, is a consolidation activity enabled by nanotechnology, particularly nanoparticles of calcium carbonate, which this is really an additive process. You're refilling kind of in a nanoparticle mechanism that substrate. So a fresco is art that's painted on architecture. Right, and as the architecture erodes, right, it endangers or imperils that artistic component. And so that consolidation was performed without actually the addition of any pigment, which really kind of demonstrates that there is a role for STEM to play in things, in objects of cultural heritage. It also helps people start to think about both sides of activities, particularly in translational applications. So obviously these kinds of things have durability beyond the classroom. So another complementary piece which really began to kind of show me how that a lot of these types of innovation activities are related is the kind of the pivot from physical interventions in conservation to digital, basically, interventions, right? And so in some cases, physical conservation doesn't really make sense either because of the state of the artifact or because of the cost involved in a physical conservation, but there are things that can be done in terms of digital manipulation. So here what I'm showing you is the Bachman Tavern that's in eastern Pennsylvania. It's a kind of a very historical landmark in eastern Pennsylvania, a part of Pennsylvania and also the national heritage. And that rendering there was a combination of LiDAR, which is light detection and ranging, combined with photogrammetry, used to construct a digital record of that object. And so really, if you think about 3D printing, the digital record is where all of 3D printing begins. And so these things begin to stitch together in kind of weird nonlinear ways that kind of seem to be the nexus of lots of innovation activities, which if you kind of listen to different talks, you realize that there's a lot of common thinking. And so again, a point of this is to show that really far-flung collaborations between foreign languages and libraries and computer scientists kind of find themselves in the area of additive manufacturing. Right, and so students that began to see how LiDAR and photogrammetry and these kind of advanced techniques in surveying can be used for cultural conservation, they started taking these high-end assets and digitally archiving assets at Lafayette College. So the leopard being, the mascot of Lafayette College, and that's the class of 1958, the kind of the bronze invested leopard that's emblematic of the college. Then they, said, well, we're LiDAR scanning buildings that I don't know anything about. Why don't we start LiDAR scanning things that are interesting to us? And so one of the first things they did was they took a LiDAR record of the leopard and then realized that when they had the digital record, oh, there's these other activities happening in the Ideal Center around additive manufacturing. Could we re-express this object? And as that started to take hold, they started scanning other objects of importance like the statue of the Marquis de Lafayette. And then all of a sudden, I'm getting telephone calls from the VP of Development saying, hey, can you make those bronze leopards for the class of 1958? Because we would really like to give those as gifts to these donors that are invested at the 7-figure level, which all of a sudden, you see kind of a combination of innovation, design, and entrepreneurship coming together where the VPs of development realize that they're tapping into a new market. And this sort of thing is really exciting because students can start to see how these things have translational implications and in some of them non-obvious ways. So let me kind of bring the focus back to additive manufacturing. And so the mission of the Additive Manufacturing Institute is to serve as a resource not just for the college and for the local community, but also for the region in terms of large format metal printing. And so that's kind of been a focus of ours. It's not the exclusive assets that we have at Lafayette associated with 3D printing, but we think that there is really an opportunity in the sense of enabling regional industrial partners in terms of metal processing. And so the strategy that we employ at the Additive Manufacturing Institute is to kind of use a a system or an ecosystem of workshops, seminars, maker meetups, and design challenges hosted by the AMI that kind of build that ecosystem and show different pathways into participation. And so what you can kind of realize is that while some of that terminology sounds overlapping, there's really different levels and different target audiences for those sorts of things, right? And so the thinking behind something like a workshop is a hands-on experience that has a deliverable element at the end by participation, right? And so we've done workshops that are introductions that tend to be populated by non-technical students wanting to understand, well, what is the basis of this technology? What are the kind of the core components? And they usually have, like Rick pointed out with outreach activities, some sort of deliverable element at the end. So they start with some kind of a CAD file and then make some manipulations or personalizations, customization of that, and I'll show you an example. And then at the end of a 2-hour period, they're prepared basically to render that file and then 3D print it. And so kind of in complement to that, we have this whole program of what we call maker meetups. And so we have kind of a diaspora or an archipelago of 3D printers at Lafayette College in all different places, and I try to stash them in places that are non-obvious, like in the library, so that students can unintentionally cross paths with the technology, and that there are clearly established mechanisms for how they could educate themselves a little bit further about how to use it. And so in maker meetups, basically the idea is that we have employed kind of student chaperones that facilitate that experience for kind of new users and new adopters of the technology so that they can kind of be guided through it, and then once they essentially become, a process of licensure, can become, a regular user themselves in an unchaperoned way. And so that's how things like maker meetups and workshops complement each other. And then we have things like seminars for more technical users that understand some of the challenges or barriers or innovations associated with continuing the technology, like using recyclable materials and filament extrusion and that sort of stuff. Those kinds of things aren't places where a neophyte would really feel very welcome, because how to process using solid state, shear pulverization, new non-recyclable materials into filament, it's not all that interesting. But there are people that are technical users that want to understand, well, what are the newest innovations? Because a lot of times students have really great ideas about how to innovate, and so hearing about what are the leading challenges is also appropriate. And then the last piece there is that we have a whole co-curriculum and what we call design challenges. And so there's different levels of design challenges, and these are essentially issued at large as co-curricular activities with different types of incentives, right? And so we framed, level 0, level 1, level 1 plus, and different types of challenges that then would be pushed out through different mechanisms like the Skillman Library or other places, where students would be incentivized to participate in some sort of a design activity, let's say at an entry level, just customizing a simple part that already had been optimized for 3D printing. And so this past year, we featured an innovation challenge, and actually the student team of 5 winning the grand prize, the $5,000 prize, actually used 3D printing to prototype their part, which was a modular water bottle that could also be used as a construction material, right? And so, the external evaluators of the program really kind of enjoyed the way in which students interacted with prototyping technologies and engineering methods, but really a requirement of participation in the iPrize Challenge is that it has to be interdivisional. The team cannot be composed of one division. So at Lafayette, there's humanities, social science, natural science, and engineering. So no team can be composed solely within a division, and no team can solely be composed of people from the same class year. Right, so they could meet that challenge by involving external participants, involving faculty or staff, or students from other class years. So it really kind of forces students to think outside the box in a way to combine these ideas into translation activities. And in fact, there were 3 provisional patents issued out of applications in the iPrize Challenge this year that are really quite interesting. And so, kind of as I mentioned, these sorts of activities have to be part of an ecosystem, and so we've also framed things from the E side of IDEAL in terms of workshop type activities that more focus on skills development. Like, for example, how would one file an SB16 form to write a provisional patent? right? And so that's, again, a guided experience where a room approximately the same size as this would be walked through. Here's an SB16. Let's take this idea, and we're going to write up an SB16. Here's a claim set, and this is what this looks like, and here's how you can go about filling out your own IP. And so students really enjoyed that and felt empowered, and to realize that for about $130 that they could file a provisional patent. And so that all of a sudden makes a lot of people think a lot more seriously about their ideas. And it's really kind of a minimal infrastructure to show students once a semester, here's how you fill out an SB16. Right? And so there's a lot of other things that are kind of in that same vein. So Wayne Bars from the Ben Franklin Tech Partnership does a how to write a business pro forma. Here's how we do a financial analysis. And let me explain to you that it's really about thinking. It's not about getting all the numbers right. Right? And so these different kinds of activities are really important as students frame innovation and particularly things like 3D printing. And as Rick mentioned with his example earlier, talking about how one can use these as outreach tools, at Lafayette we have a program called Our Beloved Community, which is a program for underrepresented students in STEM that get flown in from all over the country. And we did a 2-day workshop in the use of 3D printing and additive manufacturing as a tool for social justice through the democratization of manufacturing. So all students in that program were able to customize a finger ring and print that finger ring. And really kind of an interesting implication of that was a proliferation of all clubs and organizations at Lafayette College printing custom finger rings for different events and commemorative memorabilia. But you see really there's a very rapid pollination because the technology is so accessible. So on things like that, you don't need to use an X1 M-Flex $1 million metal printer, but you do need to have some tool, right? So the Ultimaker is a really good way to get people involved in that sort of thinking. And then there are always students that say, I would really like to do this in brass. And so that's kind of the gateway, let's say, into heavier use. So again, thinking about translational activities, very often IDEAL has solicitations from outside partners of, hey, do you have anybody that would be interested in a project in? And so one of the programs at Lafayette is our living learning community. So there are houses of students that have topical interests, and there is a 3D printing house. So students self-identified, I want to live in a house with other guys that do 3D printing. They bought a couple of 3D printers and have it in their dorm room. And I got a call from a real estate developer that wanted the capability to optimize some building designs so that they could use them as kind of business development tools for pre-built space and lease agreements. And so the students basically made beverage money for the semester by printing off these things customized to these different business development applications, but it was really a way for them to say, hey, how do I actually size out the cost of what this is to do? Like, I have the printer for free, and so we then sat through a pro forma analysis and said, let's take the cost of materials, let's imagine what hourly rate you'd like to make, let's think about amortizing the cost of your assets, here's what this price should be. Right? And so then engaging with a client in that kind of activity, it's really not a small business, it's just a kind of, let's say it's kind of a chew toy, but it helps students think about, well, what would it take to do translational activities? So when we start to think about industry partnerships, most academics, myself included, feel like she does when you approach an industry partner for a sponsored project, right? Because you have your beach towel, you have your dog, you have your bicycle, and all of the signs seem to say that no, none of this would actually work because you're asking me for money, and what I'm looking for is for a free resource. So what I would like to say to the people in the academy here is don't stop, you should keep trying. And to the people in industry, you should once in a while think about coughing up a little money. Because really the implications are pretty fantastic, and in many cases I was astounded with people in metal manufacturing that did not understand some of the capabilities that could be done with 3D printing, particularly in the foundry business. So I'm not talking about the unindoctrinated in terms of metal processing, but the capabilities of what 3D printing can do to enable, not to replace, but to enable things like foundry casting are really, really dramatic. So I want to give you a couple of quick examples of projects that we've done, and then save a couple of minutes at the end for questions. So as I said, there's kind of an ecosystem of different, we have a Stratasys, we have a 3D Systems, we have a bunch of different kind of entry-level 3D printers, but really the key assets in the AMI are the M Lab, which is the small-scale powder-based binder jet metal printing manufacturing facility, and then the M-Flex, right? So the M-Flex is a large format, it's about a 10 by 16 by 10 build envelope, which is relatively large. When that build envelope is full of metal powder, it weighs about half a ton. And so that's relatively big and can start to address relatively important commercial applications. And so I'll skip over, but in case you're interested, we'll share the details of how that process works. But the basic idea is, as Brian mentioned kind of at the top today, that there is a printing step, and then there's a heat treatment step, and then post-processing really is a very key part. And actually intermediate to that, there's also a curing step. And so when we look at these things from a commercial perspective, there's a lot of opportunity for optimization, there's a lot of opportunity for customization, and there's really a lot of economic opportunity. And I'll explain a couple of different places where we've participated with industry partners in each of these different areas. So with kind of curricular approaches, we used a client that had approached us about injection molding and rapid prototyping injection molds. And really one of the challenges with injection mold design is that it can be prohibitively expensive, so it's difficult to customize injection molds if you have multiple different molds. And so really the question is pushing the barriers associated with the tolerances typically defined for injection molds. And one of the ways that we brought student thinking to bear on this was doing it in a first-year engineering seminar, showing students that in fact you could print 3D injection molds, and that you could in fact injection mold things with that 3D printed injection mold. But really that's more about, as our colleagues at East Stroudsburg talked about, introducing to the concept of design thinking, right? And so in a way, there's really not a lot of engineering there because we want students to just understand an iterative process and meeting consumer need. And so really there's kind of different ways to step that up, and that at a capstone level, we can have student teams of 10 to 12 students working on things like injection mold optimization, and now we can really start to talk about engineering specifications, surface finish requirements, and there's really a lot of technology involved, but it's, as I mentioned, it's really part of an ecosystem of how students can become introduced to the concept of translational commercialization in the academic environment, as well as actually working on projects that are of kind of quantitative interest. And then kind of as we move even further into the kinds of activities that Rick mentioned about an hour ago in terms of sponsored projects, now we're talking about dedicated faculty, student, technician effort into activities that have direct applications for, let's say, the industry part. And these things tend to be the sorts of things that garner money, right? And so one of the problems that actually we worked with on X1 was the situation of binder optimization, is that there's the interaction of this ink with the medium into which you're printing. And so defining basically standard test methods for new binder formulation was something that was kind of out there in the sense of method development. It wasn't very near to the commercial applications, but it actually is very enabling in terms of screening new materials, because there are challenges associated with that binder interacting in a negative way as new materials come online, particularly with the metallurgy, right? So again, to spare you some of the technical details, these things tend to be projects undertaken by students with a higher degree of competence using assets elsewhere at the college, like rheometers and piezoelectric inkjet binders, droppers, et cetera. And students have to have a little bit more technical know-how. But again, these things, all of the results that I'm showing you, the concepts I'm showing you, are accomplishable with undergraduate students and, let's say, a faculty member and a postdoc or so, right? And so, I guess, kind of in the interest of time, just to give you the flavor, there's a lot of things that can be done in a purely undergraduate environment, and so this, to me, implies that it really should be generalizable to most institutions represented in the room, because you don't need whole PhD programs dedicated in material science and engineering to do things that industry cares about that have translational implications, right? And some of those assets are also accomplishable with relatively low budgets. So that's just a quick summary of what I've just mentioned, and I'd like to stop to be able to field a few questions.
Any questions for Dr. Ferry? Go right ahead.
Would you consider partnering with another college to increase the amount of, say, competitions you could do, or the amount of resources you could have, and the amount of designs that can be made throughout the semester?
I think that kind of stuff makes natural sense because the key to having those sorts of competitions thrive is by having external participation, i.e. what we started was a program in which companies or industry sponsors or external entities could write a sponsored challenge. And by a sponsored challenge, what that means is, let's say, a 50-word problem statement and some dedication of a resource towards the prize pool, right? And so the bigger is that ecosystem of having addressable prizes, right? I think the more attractive it is for an industry partner to write a sponsored challenge, right? So one of the problems that we had was we had 10 sponsored challenges and only 3 of them were addressed. So it really makes sense actually to cross-pollinate because I can't service the population of people that are requesting service.
Because ESU actually has an innovation center that does a lot of the things that you do, but you have the resources to do additive manufacturing on top of that. So I think partnering would be very good.
I think it makes good sense, and it also is an easier way, for example, to present critical mass to industry partners.
Any other questions? Go right ahead.
James, how do you take care of those printers that are distributed around campus in unlikely places?
Well, so that program of chaperones that I mentioned, so there's students that are themselves interested, and particularly the ones that live in a house called the 3D printing house. So they are kind of the core backbone of that. But Ultimakers, need, let's say, every other day kinds of interventions. So these students are trained in kind of standard, maintenance issues, and then when there's something a little bit heavier, usually we have more of a trained person to go in. But it's basically by kind of a network of volunteers, and the only compensation that the student chaperones get is first consideration and use of a scarce resource.
Okay, one last question.
Do you have any workshops throughout the summer or throughout next semester that will be open to non-Latinx students?
So we've thought about that for a long time, and we don't actually know the mechanism that would be right to push that information out in, because there's kind of, let's say, there's a lot of how would I call it, like ambient noise in programming announcements in any region. So how do you find the right venue for people to look? So maybe one of the outcomes of something like a conference like this would be to organize a means by which those announcements could be organized around the topic of additive manufacturing. I think that'd be really useful.
Okay, let's give everybody